Welcome back, guys, to another Java episode. Today, I'll be teaching you about the Java stack class. The stack is a linear data structure that is used to store the collection of objects. It is based on last in first out. Java Collection Framework provides many interfaces and classes to store the collection of objects. One of them is the stack class that provides different operations such as push, pop and search, etc. In this section, we will discuss the Java class, its methods, and implement the stack data structure in a Java program. The stack data structure has the two most important operations that are push and pop. The push operation inserts an element into the stack and pop operation removes an element from the top of the stack. Let's see how they work on stack. Here you can see the push and pop diagram where the top of the stack is pushed and popped by using the commands push and pop in the stack. Let's push 20, 13, 89, 90, 11, 45 and 18 respectively into the stack. Here, first of all, the stack is empty, then we push 20, 13, 89, 90, 11, 45 and 18. And let's remove pop 18, 45 and 11 from the stack. Here in this figure, we can see that the top of the stack has 18 in the top of the stack, and after popping 18 we get 45 and the last values respectively, and after popping 45 we get 11 to 20 after popping, and after popping 11 we get 90, 89, 39 and 20 respectively as the last values. Pop operations. Empty stack. If the stack has no element, it is known as an empty stack. When the stack is empty, the value of the top variable is -1. So when the stack is empty, the value of the top variable is -1. You must remember that. When we push an element into the stack, the top is increased by 1. In the following figure, we push 12 to the top 0, push 6 to the top 1, and push 9 to the top 2. So these are the values at top 0, 1 and 2. When we pop an element from the stack, the value of top is decreased by 1. In the following figure, we have pop 9. Top equals 1. The following table shows the different values of the top. If the top value is -1, it shows the stack is empty. If it's 0, the stack has only an element. If it's n-1, the stack is full. And if it's n, the stack is overflowed. The Java stack class. In Java, stack is a class that falls under the collection framework that extends the vector class. It also implements interfaces, list, collection, iterable, clonable, and serializable. It represents the LIFO stack of objects. Before using stack class, we must import the jar.util package and the stack class arranging the collection framework hierarchies as below. First, there's iterable, then collection, then list, and after that there's vector, and finally there's a stack class after the vector in the jar.util package. Now let's start from the beginning. Let's make a Java class called main and have a main method, and we say stack. And you can see that the java.util.stack class was imported, and inside as a type we'll give integer, and we'll call this stk, and we'll make it equals to new stack. And let's add values to our stk. stk.push is used to insert values. we'll insert 101 now, and then stk dot push 456, stk dot push 156, and stk dot push 87, and we'll have S out to print if the stk dot is empty. We'll copy this from here and paste it here, and after that we'll have an S out that prints the stack. Let's run this and check the output. We got our output. For the stk is empty, we got true because in the first instance we didn't push any values to our stack, so we got true. After that, for stk.isEmpty, after pushing values, we got false. Then we got our values which were inserted to the stack printed. 101, 456, 156 and 87 were printed according to the order they were pushed. That's how we push and use the isEmpty command inside our stack. Here I will show you an example to how to implement push and pop elements throughout our stack. First I made a static void method called push element, where I passed my stack and an int x. Here I made a stack of type integer named stack stk, and I used the stk.push to add new integer values of our int x. Then I was out at the push value and x, and after that I printed the stack. Then I made another method called push static method called static void pop elements, where I passed the stack to it, and inside it I have printed the values after popping. Integer x will be equal to integer stk.pop, and we have s out at the integer value x which we just popped, and finally we have implemented our stack again. So here, after declaring the methods, I have used the methods push element here to add values 20, 13, 9, 89, 90, 11, 45 and 18 to the stack. And I've used the pop element method to delete pop elements from the stack. And I've added a try catch to pop elements from the stack. So here I have used the try catch because an exception can be thrown. If it's thrown, it will show empty stack. Now let's run this and check the output. We got our output. First the stack is empty, then we have pushed 20, 13, 89, 90, 11, 45 and 18 to the stack. Then we have popped 18 from the stack. Then 45 was also popped, and finally 11 was popped from the stack. That's how we push and pop elements using push element method and pop element method that we just made for this example. So here the push element method pushes elements to the stack, and pop element method removes or pops values from the stack. Now we'll see another method inside our stack. We'll have a class build, class main, and we'll call the main method, and we'll say stack, and we'll implement our stack, and after that we'll give this a type of string, and we'll call this fruits. Make it equals to new stack, and let's add some values for our fruit stack. To add values we use push. So we'll say push mango, and we'll say fruits.push orange, and we'll say fruits.push grapes, and we'll say fruits.push banana. And let's print our fruit stack inside our sout. And now let's have sout to print the fruits dot peak value. And after that let's print our fruits again. Now let's run this and check the output. Before that we'll make these grapes with lowercase. Now let's have our stack run. We got our values. Mango, orange, grapes and banana were printed. Because banana is the topmost element, we got banana. That means in this stack the value banana is at the top because it's in the order of ascending order. So after ascending order is provided, banana becomes the first element inside our stack. So that's why we got banana as the peak value for this example we just coded. Alright, let's learn about the search method now. We'll remove this and we'll say int sas and make it equals to fruits.search, and we'll provide orange as the value. And after that let's print our value sas, and let's remove this out from here. What will search do? Let's check it out. We got our value. First mango, orange and grapes and banana were printed. As the 3 was printed because this int variable finds the value of the index of the orange, the number in which this orange is placed inside our stack. So because the stack's value orange is in the third index, we got our value as the answer as 3 for this example. So because in the order the index 3 is orange, we got our value as 3. That's what happened here. Now we'll see the size method. We'll have our value as string as int and we'll call this x, and inside it we'll say fruits.size. And after that let's print our x and see the size of this stack. We got the size as 4 because here mango, orange, grapes and banana are only 4 elements. That's why we got the size as 4 for this example. If we add another value, fruits.push pineapple, what will we get as the size? Let's check it out. We got 5 this time because there are 5 elements. We got 5 as the output when we ran this code. Now as you can see here, I have made another example for our stack. We built a stack without any type, and we have pushed BMW, ID, Ferrari, Bugatti and Jaguar as values to our stack. I've used in iterator equals new stk.iterator. The iterator was used here, and I've given a while clause that says iterator.hashNext. And then I made an object which is called values and made it equal to iterator.next. And finally I have shouted out our values, object values. Let's check this after running what our output will be. We got our output. BMW, Audi, Ferrari, Bugatti and Jaguar were printed as the output for our iterator methods. So the iterator helps to print out our values in order for a stack. Now I have implemented another example for the stack. Here I made an integer stack called stk and pushed 119, 203 and 988 to it. And after that I will say iteration of the stack using for each method. And then I will declare stk dot for each this time and made it n arrow out n. So here I have used a for each method for this. I made n arrow out n. So to do the for each we have to have n, and after that this arrow symbol and the brackets, and inside it we must provide our value or the s out. So let's run this and check the output for our for each method. We got our values printed in the order they were declared. 119, 203 and 988 were printed. So what the for each method does is it prints out the values for our stack by the order they were implemented inside our code. I hope you got a clear understanding about the for each method in our stack. The for each method is declared as stk.forEach, and we give these brackets, and inside we say the value. When we give the name of the value and we put an arrow sign and give curly brackets, and inside it we can give our code or the s outs, and then we close it by this bracket. Now we'll use the list iterator method. We'll declare list iterator and give it the type integer, and we'll say this itr, and we'll make it equals to stk dot list iterator, and we'll pass stk dot size to this, and after that we'll have a while that says itr dot hash previous, and after that I'll list out itr dot previous. Now let's run this and check how the list iterator works. We got our values in the order of in the descending order. We got 988 first, then 203, then 119 printed. So this list iterator gave the previous values in order. So 988, 203 and 199 were printed in the reverse order of values, of the values declared. So this is how the list iterator is used to print out values inside our stack. Now let's see a string example with this iterator. List iterator. We'll have string here and here also string, and we'll give values here as Kulesh, and the second value as Alex, and the third value as Ginger. And we'll have another value also. We say st.push Harry. Now let's see this after running our code. Okay, we got our values printed. First came Harry, then Ginger, then Alex, and lastly Kulesh were printed. So this also provided the descending order of values when we ran this code. The list iterator provided values in the descending order that were put in our stack. So that's how to find that's how to use the list iterator to print values in the descending order of values inside the stack. Alright, till here we learned many collection framework classes and interfaces and how to implement methods related to those interfaces and classes. So the lesson about the collections framework is over for today. We will discuss 11 main classes of the collection framework. So I hope you got a clear understanding about the collection framework and its methods and its objects and its classes and interfaces. So in the next day I'll start teaching you all about the design patterns in Java. So I'll see you in another lesson another time. Until then, goodbye guys, and please take care.